more on Taylor's, and you know what? You don't have it. I didn't see it. Okay, so we're going to cut this away. That's the Taylor polynomial. You can, and I can also save it. Everything's up to date on the website, so I can save it as a PDF, and you can print it out or take a picture later. Okay, so you should make sure you know this. What else do you have to know? You need to know these series. Do you know e to the x? Do I need to write them again? And really, I could have had the first one be f of a, x minus a to the 0 over 0 factorial. So you can see the pattern. Did I forget the factorials? Yes, I did. There it is. Yeah, it should be factorials. So, I mean, how do I remember this? This is 1 plus x squared plus x cubed, and that's x to the n. And don't forget to think of the relatives for that. 1 over 1 plus x is a relative. And we can do more. We'll do more of these next week, but some of you won't be here. But I can make a video. Well, what's e to the x? It's 1 plus x squared over 2 factorial. This 1 factorial plus x cubed over 3 factorial. See the patterns? How they're similar, but they're not the same. X to the n over n factorial. Right? What's the sign of x? Sign is odd, right? And they're alternating signs. So I'm only going to take the odd exponents out of e to the x. So it's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, etc. And this is x to the 2n plus 1. Whoops. I'll write it out. Negative 1 to the n over 2n plus 1 factorial. If I take the derivative of this, either side, they've got to be equal. What's the derivative of the sign? Cosine. So if I took the derivative of the power series, I'll get the power series for the cosine. But I happen to know it. Okay, so this is even, so I'm going to take the even powers. 1 minus x squared over 2 factorial. So all I have to really know is e to the x, and I got all the rest. At least I do. Nick, put that away, please. You. Drexler. Okay, minus. I want you guys to get good scores. You can get good scores, just pay attention, that's all. Because 1 is x to the 0, so that's even. And this x up here is x to the 1st, so that's odd. Those are questions you have to ask. I see it, but I have to think. I always go, which way do I start? Sine is odd, so you get the odd exponents. Cosine is even, so you get the even exponents. X to the 0 is even. 0 is even number. Because I know the sine function. Sine function looks like this. Not a very good sine function, but whatever, it's odd. Okay. If we could do that, what would you do with this one? The power series. Okay. And in this one, you take e to the x, and you put in minus x squared, and then you integrate. This is what we did in the evening sessions. How about that one with L'Hopital? Why? It's just 0 over 0. If you get 0 over 0, then you just take the derivative of the numerator. By the way, you could use a power series if you'd rather. L'Hopital says this is the limit. What's the derivative of e to the x? E to the x. Derivative of minus x is minus 1 over 2x. Now we put in 0. Guess what? I still get 0 over 0. So we have to do L'Hopital again. If it's free response, you must write 0 over 0. You will not get the points. And so this is derivative of e to the x minus 1 is e to the x, and this is 2. Now you put the 0 in, so it's 1 half. Now, do you guys know how to find the second derivative in example 1? as long as you get 0 over 0. But you must simplify before you go on. So if you get some sort of complex fraction, then you're going to have to simplify it. You guys, put your games away. Griffin. Why? Okay. What's the first derivative of this function? Because it's the coefficient of this. What's f double prime of x? Well, f double prime of x over 2 equals that coefficient, which is 2/3. So what's f double prime of x? 4/3. Couldn't you do what? You got to be careful with this. What's the third derivative? It's f triple prime of x over, actually it's on my thing there, over 3 factorial will equal this coefficient, -3/4. And then you solve. So it's the derivative is not just the coefficient. So what if I ask for the 10th derivative? Well, the 10th over 10 factorial. Now looking at my nth term here, what will the denominator be? 11. N plus 1. And it's negative. Now you do have to watch out that -1. -1 to the 10 times 10, and then the x to the 10th will go. Oh, we can't. How did I do that? That was an interesting. I probably did something with it, but anyway. Yeah, there we go. So the 10th derivative is -1 to the 10th times, which is -1, 10 factorial over 11. Because they might ask that. The x's are gone. It's just the coefficient. So this is equal to the coefficient there. The 10th derivative divided by 10 factorial. Okay, they could ask you that. They haven't asked that for a while, so I kind of think they might. Okay, guys, there are your multiple choice questions. Let's do Taylor polynomials for all the exams. That's all we got. And I want to bring up, we could do any and all of these. Let's do, that one is a physics question, really. It's a vector, but it's a physics. Yep, we're going to do it right now. Let's take 2008. I also want to look at 2011. I don't care which one we do first. So you should do that. Try that right now. The only thing you don't know how to do on this problem is part C. And they say use Lagrange. No. And it's 2 points. So, you know, is it worth it? It's worth it. Actually, it's not that hard. Can you? How are you going to do the first one? Okay, well, here's the Lagrange error bound. Now, alternating series, it's very much like the alternating series. The alternating series, you take the first discarded term. Guess what? You do the same thing with the Lagrange error bound. But the first discarded term is going to be a Taylor polynomial element or whatever. So if you end up like this is your end of your Taylor polynomial. We're doing this at 1.9. Yeah. No, it's at 2, sorry. And it's x minus 2 to the nth over n factorial. So that's where you end. Let's say it's the third term. This case, it's going to be what? Third degrees, where we're going to go. So I'm going to go to the one right after it, which is the n plus 1 derivative, x minus 2 to the nth over n factorial. So it's exactly like the alternating series. Okay, David, you're not going to get this. It's not that hard to get. It's exactly like it. It's still the same thing. It's just going to use this term because that's what a Taylor polynomial looks like. And the only thing that's different is you want the maximum value here. The maximum. So, Sarah, if it were a sine function, and no matter how many times I take my derivative, what's the maximum value of the sine function? 1. You could go bigger than that. I could make it 2. The problem is they say I want it less than a certain value. This was a calculator problem. So if I make my maximum value too big, I could randomly say, oh, let's put 100 in there. It won't be smaller than 3 times 10 to the negative 4th. Not explaining why it works or anything. This is just how you do it. So we are going to write the first 3rd-degree Taylor polynomial, and I want to know the difference between the actual value, h of 1.9, and the Taylor one. So I'm going to write actual minus t of 1.9. I want that to be less than 1 over 30,000, right? Did I do my scientific notation right? And so we have the third one. So which derivative are we going to take? I want what? I want f. If we do the first 3, I want f of what? Which derivative? 4 of, okay, Zach, of 2 over 4 factorial, and then it's going to be x minus 2 to the 4th. But what am I going to put in for x? Where am I doing this? I'm doing it at 1.9. Now, where am I going to get this 4th derivative? The table. Which one do I want? I want the 4th derivative. Where am I centering it? Centering it at 2. So I want that. You got a point for knowing which one it is. So it wasn't that bad. So it's 584 over 9 over 4 factorial. And then this is 1.9 minus 2 to the 4th. I have full points for that. That's all you have to do. But you have to get the maximum value. Well, guess what? They gave it to me right there. So let's do, and I know I'm pretty sure I don't have it in my slideshow here, 2011. Okay, should we check it? You get, excuse me, you get a form, you get 1 point for knowing it's what I just talked about. Knowing that it's the maximum, that's it. What can I say? Not that hard. Okay. What about this one? Look at this one. Tell me which error is it. Let's just focus on the errors. Chris, which error is it? Is it Lagrange or is it alternating series? It's alternating series. They don't tell us that like they did last year. Okay. It says explain why the estimate found in part C differs from the actual value by less than 1 over 200. How many terms do we use? We use the first 4, so we need the 5th term at what value? At 1/2. And that will be less than 1 over 200. Got the answers right here. I just don't know what the 5th term is. So you go in there and you do this. Pardon? 3rd term. I thought we were on. Oh, wait. Did I read it wrong? Oh, sorry. Read the first 2. Read it. The 3rd term. We might have done this one. I don't remember. I've done so many of these, I don't remember. Okay, sorry. I used the wrong term. It's the 3rd term we're going to use because I didn't read it carefully. You must say alternating series. Okay, so now I'm going to bring up 2011, and well, we'll do the error thing, but you should go back and do the other thing. Did I open it? Let's see. I swear I had that. Okay. 1 second here. I swear I had it. I probably do. I just don't know where it is. Oh, I had it up. You guys should be working on the first part of 2011. There it is. Sorry, that's going to come out weird. Okay. Okay, this one bothered me because I'd never seen one with a graph before. Okay, Eric, Sarah. Here's one where they ask you for the sixth derivative, just like we did the 20th, so it's the same kind of thing. And it says, use the information from the graph. They give you the fifth derivative to show that the error using the first four terms is less than 1 over 3,000. So I could just recopy that, no big deal. Minus f of 1/4. Now, that's the first four. So what does that Lagrange error bound say? It's less than the fifth derivative at, where are we writing this? Around 0? Of 0. Actually, it's on the interval over 5 factorial. And then it's x minus 0 to the fifth power. So this is the hard part right there. What's the x value? 1/4. So it's 5 factorial. That's 1/4 to the fifth. And now you just have to find the maximum value of the fifth derivative on this interval. Okay, Eric? Put that away, please. What's the maximum value? It's this point right here. Do we really, guys, do we really know where that is? Okay, Matt, you're not going to know how to do this. Well, I don't even know. What is this? This is 60, 40, that's 20. Maybe it's 30, maybe it's 35. I don't know. So you know what I'm going to use? 40. Could you use 80? Yes. Except the problem with 80 is it doesn't satisfy that condition. But I would go to the next biggest one you know for sure. Because you don't know for sure that 35 is the biggest one. Okay, Zach? So we're going to put in 40. So I need to know for a fact it's 1 over less than 1 over 3,000. 3,000 I can talk. I've been talking too much. So I just write it out. 1/4. And it's 5 times 4 times 3 times 2 times 1. So if I do this 40, that leaves me 10, right? So if I simplify that a little bit, that is 10. Pardon? Oh, yeah. Although 10 is easier, but okay. Yeah, there's the 10. You're right. So it's 1 out of 4 to the what? 1, 2, 3, 4, 5 times 3. Well, you can do it by hand. That's sufficient. Should we see how big it is? You could get your calculator out. 3,072. But this is probably good enough. Okay, you get a point for knowing it's the maximum on that interval. Putting in the 1/4 here, you get a point for that. And then you get a point for your answer. Basically, to me, it's 2 points right or wrong. Because if you got that, I mean, that's obvious. But I would have written down the Lagrange error bound, even if I didn't know I had to go to that graph and figure it out from here. I didn't know how to use the graph. But they'll either give it to you, and notice I can only find 2 problems with this in there. They're alternating series. Almost all. Okay, so, we did this problem. We didn't finish it. Didn't we do it? We did do it. Yeah, we did. We just didn't finish it. And I went and did it again at night because when they're asking for the sum of these series, you have to combine this one with that one. So it's negative x to the 6th, and it's 1 over 3 factorial plus 1 over 6 factorial. That's what this number ends up being. 121. Do you understand how to do C?
Yeah.
Where are you going? So the question is, do I need to come back Monday night or stay after school Monday night? So by Monday, figure that out. Who's coming over, by the way? Who thinks they're going to come on Sunday? Oh, no, you don't come for the whole time. Some people come for the whole time. Noon.